Hi students, how are you all? I'm back with the Numericals of Archimedes. As I told you in the first part of this video, first part of Archimedes Principle. You have not seen that video? Don't worry. The link of that video is there in the description box. You can check that. And in first part of Archimedes Principle, we discussed that when you are taking the weight of an object at air, say I am in air and I am measuring my weight. Say my weight is 100 Newton. Say my weight is 100 Newton. Then when I immersed in water or in any other liquid, then the weight of mine will reduce. Yes, I told you that when you are measuring the weight of an object inside water or any liquid, the weight of that object reduces. Why? Because the object feels an upward pressure. No, the object feels an upward pressure. Who gives that upward pressure? The liquid gives that upward pressure. Okay? And that upward pressure is called buoyancy, force of buoyancy. Understood? That upward force which the object is feeling, the object which is immersed in that liquid, that force is called force of buoyancy. Understood? And I told you that how to calculate force of buoyancy in that part. But you must see the first part before seeing this part, that is second part of Archimedes Principle. And I also told you that in Archimedes Principle, the first part, what is Archimedes Principle? Archimedes Principle is when you immerse an object in a liquid, then the weight of that liquid reduces. How much the weight will reduce? The weight of displaced liquid. Yeah, you know displaced liquid, like you can see here, which we discussed in the first part. When you are measuring the weight of an object, say you are taking a stone and you are measuring the weight of that stone in air, say it is 5 Newton. But when you are measuring the weight of the same stone inside a liquid, you are getting 4 Newton. Why? Because the object is getting an upward force. Okay? That upward force is called force of buoyancy. Fine. Who is giving that force of buoyancy? Force of buoyancy, this liquid is giving. Okay? And the direction of force of buoyancy is always upward. Okay? That's why the weight of the object reduces inside any liquid. Understood? So, and what I told you that 5 Newton in air, 4 Newton in liquid. How much weight is reduced? 1 Newton. And also I told you in the first part, the weight of this displaced liquid is 1 Newton. Fine. Means the weight what is reduced. In air it was 5, in water or in the liquid it is 4. So how much is reduced? 1 Newton. 1 Newton is the weight of the displaced liquid by that object. And this is Archimedes Principle. So what is Archimedes Principle? Archimedes Principle says that when an object is immersed in a liquid, then its weight reduces. And that reduced weight equal to the weight of the displaced liquid by that object. So now we are ready to start the numericals based on Archimedes Principle. Let's start. See the first numerical, the weight of an object in air. This one. The weight of an object in air is 210 GF. Okay? And the weight of the same object when you have immersed the object in kerosene. Yeah, kerosene is mentioned here, is 200 GF. Fine. So the object's weight is 210 GF in air. and 200 GF in kerosene. Let us draw it. This is the vessel and this is kerosene. Fine. Now this is the object whose weight is 210 GF in air. This is air. And same object is now immersed here. So when you immerse the same object in kerosene, then the level of kerosene will go up. Say now the level of kerosene is here. Okay. Fine. So we can say that this much is the displaced kerosene. Right. So we can say it displaced kerosene. Okay. Now, if I ask you, what is the upthrust? Upthrust equal to what is the weight in air minus what is the weight in kerosene? What is the weight in air? 210 minus 200. Okay, it's 10 GF. This is upthrust. Means the object is getting a force upward. The object is getting a force upward by kerosene. That is upthrust. How much? 10 GF. Now what is force of buoyancy? This is only the force of buoyancy. So upthrust or force of buoyancy. Okay? Force of buoyancy and upthrust are same. That is 10 GF. As I told you, when you immerse an object in a liquid, then the object feels an upward force, which we call, yes, force of buoyancy or upthrust. This is the upthrust. Now, if I ask you, what is the weight of displaced kerosene here? This is the displaced kerosene. Now, if I ask you, what is the weight of this much kerosene? Okay. So, weight of this much kerosene is the force of buoyancy. Okay, what is the force of buoyancy? 10 GF. So 10 GF is the weight of displaced kerosene. Got it? See the next question. In the next question, a ball is completely immersed in water. Fine, I repeat, a ball is there which is completely immersed in water. Now, the density of the ball is given. Volume is given. We have to find what is the weight of that ball in air and what is the weight of that ball in water, and also we have to find the upthrust. So let us find the weight of that ball in air. So what is the weight in air equal to? We know that weight means mass into gravity. Mass into gravity. What is the mass? Mass means volume into density. So volume into density into gravity. What is the volume of this object or the ball? The volume is 100 centimeter cube. So this is 100 centimeter cube. Density 7.8 into 10 to the power 3. Okay, kg per meter cube into gravity. Gravity is 10 meter per second square. Okay, but there is a problem. This one and this one, I mean density and gravity, both are in SI system, but the volume is in centimeter cube, means CGS system. So we need to convert the volume in SI system first. That means centimeter cube to meter cube. Let us convert it. Equal to 100 by 1, 2, 3, 4, 5, 6. Yes, by 6 zeros you have to divide it to convert it into meter cube. So now this centimeter cube is in meter cube. So easily you can calculate now. Let us calculate them into 7.8 10 to the power 3 into 10. Now 00 cancelled. So 1 by 10 to the power 1, 2, 3, 4. 10 to the power 4 into 7.8 into 10 to the power 3, and this is 10. 10 means 10 to the power 1. So 10 to the power 3 into 10 to the power 1 means 10 to the power 4. 10 to the power 4, 10 to the power 4 cancelled, equal to 7.8 Newton. So this is the weight of that object in air. Understood? Now we will calculate what is the weight of that object in water. But to find the weight of the same ball in water, we have to first find the upthrust or the force of buoyancy or the weight of the displaced water. Let us draw it. This is the vessel. Fine. This much water is there. Okay. And when the ball is immersed here, the level of water will go here. So this is the water displaced. Okay. This much is the water displaced. We have to find the weight of this much water. Understood? What is the weight of this much water? Weight of displaced water. Fine. Now to find the weight of displaced water, we'll use the formula. The same formula, weight equal to mass into gravity. Mass into gravity. Mass means volume into density into gravity. Now volume. What is volume? Volume of this much water means the volume of this ball. We discussed in the first part of this Archimedes principle. We saw that when you immerse a ball or an object in liquid, then the displaced liquid, the volume of that displaced liquid and the volume of that object become same. That means the volume of displaced liquid, that is water, and the volume of this ball will be same. Okay. So what is the volume of this liquid? Volume of this liquid means volume of this ball, that is 100 centimeter cube, but converted into meter cube. So 100 by, same way, the way we have done in the previous portion, into density. Density of water. What is the density of water in SI system? 1000. Into gravity. What is the value of gravity? 10. Now, 00, 00, 000, 000, 000, 000. So that is 1 Newton. Fine. So 1 Newton is the weight of displaced liquid. Understood? That means what will be the weight of the ball in water? I mean number C. What will be the weight of this ball in water? Weight of the ball in water, weight of the ball in water equal to weight of the ball in air minus force of buoyancy. Understood? So what is the weight of the ball in air? We calculated it, 7.8 it was. So 7.8 minus upthrust or force of buoyancy or weight of the displaced liquid. These three terms are same. Understood? What is the weight of this much liquid and what is the upthrust or what is the force of buoyancy? This all are same. That is 1 Newton. So just minus 1. So we are getting 6.8 Newton. That is the weight of this ball in water. Understood? So first we saw that what is the weight of the ball in air. It was 7.8 Newton. and then we calculated what is the weight of displaced liquid, displaced water. Yes, then what will be the weight of the ball in water? Weight of the ball in water equal to weight of the ball in air minus force of buoyancy or upthrust or weight of the displaced liquid. See what we have done here, and we got 6.8 Newton. Understood? Let's see another sum. See the next numerical. In this numerical, a cube is given. Cube whose side is 5 centimeter, density is 7.9 gram per centimeter cube of that cube. Okay, and the cube is suspended in the liquid. Okay, let us draw it. Let's say first of all, what do you have to find? You have to find the weight of the same cube in air. What is the weight of the cube in air? We know that the formula weight equal to mass into gravity. Mass means volume into density into gravity. Let us use that. So weight in air equal to mass into gravity. What is mass? Volume into density. Volume into density into gravity. What is the volume? Side is 5 centimeter. What is the formula of volume of a cube? Side cube. That is 5 cube. Means equal into, what is the density of the cube? Is 7.9. 7.9 into gravity. Gravity is 1000. Here I am using all the values in CGS system, because all the values which are given here in CGS system. So why to change it? We are using all the units in CGS. That's why the value of gravity in CGS system is 1000. Okay, which is 10 in SI system. Understood? So let us calculate it. 125 into 7.9 into 1000. Okay, equal to 987500. This dyne. Since it is in CGS system, so what is the unit of weight? Is dyne. Got it? So we got the weight of the cube in air. Now let us see the question. We have to suspended this cube in a liquid. Okay, the cube is suspended in a liquid. Let us draw it. This is the vessel. Okay, and here is the liquid. The liquid we do not know. The liquid is mentioned here, so we are also writing here liquid. We do not know what liquid is there, but the density of the liquid is given 1.1 gram per centimeter cube. Fine. Now here I am placing a scale. Okay, a simple scale is placed here so that I can hang this cube. Okay, this is the cube which is hanged. Okay, by using this thread. By using a thread, here I am hanging the cube. But the cube is completely immersed in that liquid. So when the cube is immersed in that liquid, then the level of the liquid will go up. The level of the liquid. So this much is the displaced liquid. Okay, this much is the displaced liquid. Now if I ask you what is the upthrust or what is the weight of the displaced liquid or what is the force of buoyancy, all the calculations are same. Let's see. So what is my upthrust? Upthrust means the weight of this displaced liquid. or the force of buoyancy. So what is that? Means mass into gravity. Mass means volume into density into gravity. Okay. Now what is the volume? As I told you, when an object is immersed in a liquid, then the volume of that object and the volume of the displaced liquid are same. So this is the volume of, so what is the volume of this displaced liquid? This is the displaced liquid. What is its volume? Its volume is volume of this object. What is the volume of this object? Side is 5. So volume is 5 cube. That is 5 cube. What is the density of this liquid? 1.1 into gravity is 1000. We know that. I told you in CGS system. So 5 cube means 125 into 1.1. That is, I am writing not point, that 10 into 1000. Okay, 0 0 cancel. 125 into 11, 125, 125, 5, 1375, 1375, 1375 00. Yes, this Newton. Understood? So this is the upthrust. This is the upthrust or force of buoyancy or the weight of the displaced liquid. So we got upthrust. And what is the weight of the cube in liquid? Weight of the cube in liquid equal to weight of the cube in air minus weight of the displaced liquid. Let us find it. So what is the weight in liquid? Weight in liquid equal to, weight in liquid equal to, what is the weight in air? Weight in air we have seen just in the previous part. It was 987500. 987500. This is the weight in yes, air. We have calculated it. Now what is the weight of the displaced liquid? Weight of the displaced liquid, that is upthrust, is this much. Oh sorry, this is not Newton. This will be dyne. Since we are calculating in CGS system, so this is dyne. Now what is the weight of the displaced liquid? 137500. 137500. So what answer we are getting? 850000 dyne. This is the weight in liquid. Okay. So what is the weight in liquid? This one. What is the weight in air? We have already calculated. What is upthrust? This is the upthrust. Now the last portion is tension. Tension means when you are hanging something by using a thread. Okay, say this is an object, fine, and you are hanging this object by using a thread. Okay, so because of the weight of this object, where the direction of the weight? Direction of the weight is downward. So to overcome that force, I mean the force of the weight, the thread is also giving a force upward. You understood? I'm saying because of the weight of this object, where this weight is, what is the direction of this weight? The direction of this weight is downward. But to overcome that force, this thread is continuously giving a force upward. The thread is continuously giving a force upward. That force of thread, this upward force is not force of buoyancy. Don't mix it up. Don't be confused. This is the upward force for this thread. Okay? That is tension. This is tension. This tension we have to find. Okay. So what is tension? Just try to understand. This is an object. I am hanging that object by using a thread. Okay. But the object wants to go down. Why? Because of its weight. Okay. Because of its weight, object wants to go down. But the object is not going down because the thread is giving an upward force. Okay. The thread is giving an upward force. That is tension. Okay. That means how much force it is giving, how much is the weight of that object. Okay. Now where is the object? Object is in the liquid. So what is the weight of the object in liquid? Weight of the object in liquid is 85 this time. This is the weight of the object in liquid. So how much tension the thread is giving, or what is the tension of this thread? Tension of the thread is the weight of the object. Weight of the object in liquid is, that is the tension. So tension equal to 850000. Understood? And here all the things, all the units are in CGS system. So the important thing is, after going through the question, you have to see which things are in CGS unit, which things are in SI unit. If all the things are given in CGS unit, go for that. Don't change them. If you see all the things are given in SI system, go for that. Don't change it. If you see there is a mixture, like few are in CGS, few are in SI, then you need to convert them. In the second sum, before this sum, the volume was given in CGS, but other things are given in SI. So the volume we converted in SI system. But in this sum, all the things are given in CGS. That's why I have not changed it. Okay. So in this way, you have to calculate this. And one more thing you have to remember, that in CGS system, the value of gravity is 1000 centimeter per second square. Okay. And in SI system, the value of gravity is 10 meter per second square. Okay. Understood? 10 meter per second square, and in CGS system it is 1000 centimeter per second square. Got it? So in this way you will calculate and you will solve these sums. Understood? Thank you.